Hello, this is video number 29. I promise this will be shorter than the last two. This is chapter 11, section 6. And this is about counting principles. So there's going to be a lot more writing in here than actual math. So ready? Here we go. All right. The first statement is this is all about counting and introduction to probability and things. And it talks about events occurring and that kind of thing. So this is about the addition principle. And it says if one event can occur in m ways and a second event with no common outcomes, can occur in n ways, then the first or second event can occur in m plus n ways. All right, so no common outcomes. They're completely separate from each other. So here's an example. I'm going to just flip to another screen. You can write something down if you like. It says, a company sells customizable cases, offers cases for tablets and smartphones. There are 3 supported tablet models and 5 supported smartphone models. The addition principle tells us that we can add the number of tablet options to the number of smartphone options to find the total number of options. By the addition principle, there are 8 total options. Okay, so the outcome of the tablets has nothing to do with the outcome of the phones. One does not depend on the other one. And so you just add them all together and you get a total of 8. Okay, so addition principle. All right, next, the multiplication principle. If one event can occur in m ways, my glasses are falling off my head, and a second event can occur in n ways, after the first event has happened. That's important. Give you a good example of this in a minute. Has happened, then the 2 events can occur in m times n ways. All right, I have another illustration for you here. This has to do with you are going to dinner and you get an appetizer. And then you get a dinner, your main course, and then you get dessert. I don't even know how to spell dessert. I think that's right. So you have X number of choices for your appetizer, Y number of choices for your dinner, and Z number of choices for your dessert. How many possible combinations can you get? right? That's basically, and your appetizer has to happen before your dinner. This happens first, this happens second, this happens third, unless you're getting extremely poor service. They're going to come in that order. So then you have X times Y times Z is the answer to that question. So here is a layout for that. So you go somewhere and your appetizers are soup or salad. There are two options for your appetizer. And then your entrees are chicken, fish, or steak. Now, they're the same over here, so we don't count them twice, right? Chicken, fish, or steak, chicken, fish, or steak. There are three. Oh, my goodness, look at that. And then the desserts are either cake or pudding, cake or pudding. I mean, they're on here 15 different times, but those are the only two options. So cake or pudding. So 2 times 3 times 2. So there are 12 choices or 12 different ways that you could have that dinner created for you. Okay, so that's the multiplication principle. All right, so let's go back here. Oops. We're going to just keep on putting some things down here. All right, we're going to add to the multiplication principle. Gosh, it's being touchy. My goodness. It's being super touchy. I want to make this go boink. There we go. All right. So this says the multiplication principle can be used to solve a variety of problems. Where objects being placed in order matter. So letters can be arranged into words. Digits are arranged into numbers. People arranged into a line. And I mean, there's a million different things that you could pick there. So an ordering of objects is called a permutation. Okay, so that's an important math word that we're going to go forward with here. So given n distinct objects, the number of ways to select R objects from the set in order is, I'll just put this here. P to the n r is equal to n factorial over n minus r factorial. Now, you might also see this as NPR, just like we saw the NCR in the last chapter. Those two mean exactly the same thing and are interchangeable. Okay, so here's an example of how this could be given. A club of 6 people. Here's an example. A club of 6 people needs to select a president, a vice president, and a treasurer. How many ways can 3 officers, be selected from a 6-member club? Okay, question mark. That's not a period. All right, well, what we're going to do here is we're going to say we want a permutation from 6. We're going to choose 3. So 6 choose 3. That's how that's stated. And then using the formula up above, the n is 6, so 6 factorial over 6 minus 3 factorial. So we have 6 factorial over 3 factorial. So we have 6 times 5 times 4 times 3 times 2 times 1. Now you could stick these into 3, 2, 1, 3, 2, 1. So we have 6 times 5 times 4. Well, 5 times 4 is 20 times 6 is 120. So you have 120 ways that 3 officers can be chosen from a 6-member club. Okay? So there is one example of how that happens. Now, there's a whole bunch of different examples of the way that can happen. That's just one, but we're going to move on to a combination. When order does not matter, then combinations can be used. And we saw those in the last chapter. We have C, n choose R. Combination of n choose R is n factorial over r factorial times n minus r factorial. And you guys have already used that formula. So here's a word problem example. An ice cream shop offers 10 flavors. How many ways can you choose 3 flavors for a banana split? Well, we're going to do 10 choose 3. I put that into a calculator. And I got 120 different ways. All right. So that's an example of how to use them. Permutation, order matters. Combination, order does not. When you jump into varsity, the first bunch of problems are just going to have, well, I'm not going to do any more examples. This is it for this video. When order does, did you catch this? DOES. When you go into varsity, they're just going to have a bunch of different problems. Also, there's probably one more thing. Oh, I saved that on my phone. So there's some card problems. And I don't know, in a deck of cards, Some of you may be card players and some of you may not. So there are 52 cards. There's 4 suits. They are hearts, spades, diamonds, and clubs. Each suit has 13 cards. So each suit has 13 cards. And those 13 cards go ace, that's a 1 essentially, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And that's 13 of them. So your diamonds, hearts, spades, oh boy, kind of looks like an upside down heart with a stem. And then the club is like a 3-leaf clover kind of with a stem. Okay, so if they ask you, like, you know, I don't know, how many different hands of 5 cards can be used in 52 decks? The next one's about probability, and you're going to have to, like, if you pick 4 aces out of a deck, what's the probability of that happening? So you need to know a little bit about decks of cards and suits and things. So, all right, well, that's it for this one. Toodaloo.